So here we have the blueprint of the device that we will be using for this experiment. So as you can see in the bottom, we have the base. So our base is made up of manila paper. It was shaped into a cup so that we would be able to place the egg inside. And we made sure that the bottom part of the base is thicker than the other side so that it will hold the strongest support on the egg. And also, we have the yarn. So the yarn is 50 centimeters long and it will attach the canopy of the parachute device to the base. So to be able to connect the yarn, we punctured holes on sides of the base. And also here at the top part, we have the canopy of the parachute device that we will be using. So it is made up of manila paper, and we also punctured 4 holes so that we would be able to connect the other end of the yarn. Also, to be able to secure the yarn from the base and the canopy, we taped the punctured holes, and in the base where the egg is placed, we surrounded the egg using the tape so that it won't fall off when we drop the device, and it will secure the egg from the base. So for the definition of the materials, we have first the egg. It is the biological weapon that should be kept safe in this experiment. Then we also have our manila paper. It serves as the canopy like the parachute that traps air to decrease the gravitational push. It also serves as a protective shell that protects the device from breaking when performing the test. Then we have our yarn. So our yarn is used to hold and attach the package to the manila paper or the canopy. Its durability and strength enables to resist the stress, and it's holding the design when it drops. Lastly, we have our tape. Our tape secures the yarn and the egg. So in constructing the carrier of our experiment, the first thing we did was to make the cup-shaped manila paper that serve as the base of our egg and to hold it as a support. Make sure to make the bottom part as thick as you can to prevent the egg from breaking. Then, we cut 4 strings of yarn. Each yarn measures 50 centimeters in length, and after cutting the yarn, we proceed to cutting 1/8 of the manila paper, which serves as the parachute for the device. After working on the individual materials, we assembled them all together, and in assembling, we punched 4 holes on the 4 sides of the base and connected the yarn in each holes. We also taped each of the sides of the hole to secure the yarn. Then, we punched 4 holes on the manila paper, which served as the canopy for the parachute, and connected the other end of the yarns from the base to the canopy. After completing the carrier, we placed the egg on the base and secured it tightly using the tape to avoid it from breaking or dropping on the ground easily. The science behind the egg drop experiment is found in Sir Isaac Newton's laws of motion. So, as what we all know, the first law states that an object at rest will remain at rest, and an object in motion will continue to be in constant motion unless acted upon by an external unbalanced force. This law means that if the forces acting on the falling egg are equal, it will remain in its current state of motion. and if a force greater than those acting on the egg are applied, it will accelerate. On the other hand, the second law is applicable to the experiment as force is inversely proportional to the mass of the egg. Accordingly, reducing the amount of mass that covers and protects the egg also reduces the amount of force it exerts as it falls to the ground. Manila paper, which mostly covers and protects the biological weapon, is compactly built to ensure durability, thereby reducing the amount of force exchanged between the ground and the egg, decreasing the impact on Newton's law of action-reaction. So in order to prevent the egg from breaking, the protective device guarantees to minimize the force of impact from a falling egg by using materials that allow for a bounce. So the objective of this experiment is to keep the egg from breaking as it decelerates. It becomes clear from Newton's laws that in order to minimize the force experienced by the egg at impact, designing the egg carriers must increase the time over which the egg is brought to rest or decrease the egg's velocity at the time of the crash. Therefore, in order to decrease the egg's velocity upon impact, the design of our egg carriers has to increase the air resistance. An increased surface area on the carrier, such as a flying disc shape or a parachute wherein we used Manila paper, caused the egg to hit the ground at a lower speed. The cup-shaped Manila paper that we've also created kept the egg from stopping instantly when it hit the ground. The egg continued its motion for a few nanoseconds while decreasing its force. For the disaster and risk, the experimentees worked on a project to test a solution on how to prevent an object from breaking when falling on a certain height. The experimentees used an egg as the object to be dropped from a certain height, which measures 1 meter, 2 meters, and from the second floor. The experimentees also tested the feasibility of an homemade parachute when used as a factor to prevent the object from breaking when dropped from a certain height by having the egg glide into the air instead of directly falling, which will result into the breaking of the egg. A parachute, on the other hand, is a device used to slow the motion of an object through an atmosphere by creating a drag. The odds of a parachute to fail is so low, it may be 1 in 1,000, but it is never 0. And also, the risk will be higher, especially if there are complications in the parachute. So, in the experiment, the experimentees considered the following complications that might affect the experiment when using the homemade parachute. First, the parachute cannot support the weight of the egg. Then second, the size of the parachute compared to the egg affected the drop. And lastly, there are issues regarding the materials used to make a parachute. There are also external factors that we have to consider. First is too much wind that could affect the parachute when it is dropped. And second, the unexpected weather. So, in this experiment, complications are listed to prevent further problems and delays that might complicate the conduct of the experiment.